One more piece in this section, complex fractions, as if you didn't think they were already complex enough. These are when we have fractions in fractions. And I don't know about you, but that just looks exciting to me. But we don't like that. It looks messy. We want to clean that up. And we probably don't want to deal with doing subtraction on top, addition on bottom, and then having to do division with fractions. That's just a lot of steps. So what we're going to do is multiply the top and bottom by something that will eliminate all of those fractions. So between 2, 5, 10, and 4, what would the common denominator be of all of those denominators? So 2, 5, 10, 4. 10 would take care of 2, 5, and 10, but 4 doesn't go into that. So the next thing that would get us 4 and 10 would be 20. So our common denominator is 20. So watch what happens if we just take our numerator and multiply by 20, and our denominator and multiply by 20. Because again, 20 over 20, we're just multiplying by 1. And we make sure to distribute that to each of the terms. So half of 20, so 20 times a half, or 20 divided by 2 times 1, that's going to leave us with 10 minus 2/5 times 20, so 20 divided by 5 is 4, times 2 is 8, so 10 minus 8 on top, and then we work on the bottom. 20 times 1/10, so 20 divided by 10 is 2, times 1 is 2, plus 3 over 4, so 20 times 3/4, 20 divided by 4 is 5, times 3, 15, so we have 15 there. So then 10 minus 8, that's 2, 2 plus 15, 17, and there we go. We didn't have to worry about doing the subtraction or the addition of fractions. Just multiply top and bottom by whatever will eliminate all of your denominators. So let's take a look at a little bit more complex of a complex fraction. Here we have 6 over x minus 5 plus 1 over x divided by 3 over x minus 2 over x minus 5. Look at the denominators, and we see that we have x and x minus 5 on the top and x and x minus 5 in the denominator. So we're going to just multiply top and bottom by x times x minus 5. Because again, we're still just really multiplying by 1 when we do that. Now when we take this and distribute it to 6 over x minus 5, the x minus 5 will cancel with x minus 5. And so we're left with 6 times x. So that piece right there would give us a 6 times x, so 6x. When we send it to the plus 1x, the x would cancel with the x, and so we would have 1 times x minus 5. So 1 times x minus 5 is x minus 5. Down to the denominator, 3 over x. The x will cancel with the x. And here we would be left with 3 times x minus 5. So 3 times x minus 5 is 3x minus 15. And then here we have to be careful with this sign, because we have minus here. But the x minus 5 cancels with the x minus 5. So we would have 2 times x. So down here we have minus 2x. Combine like terms on top and bottom. That gives us 7x minus 5 over x minus 15. Last one to look at. What is it that's going to eliminate all of those denominators? Well, we have an x minus 3, so we're going to put an x minus 3 out here. All right, so that takes care of this denominator, that takes care of this denominator, and we need an x squared to take care of that last one. So x squared and x squared. Distribute those in. On the top, x minus 3 will cancel with x minus 3, so we just have 6 times x squared. So 6x squared is our entire numerator. Then on the bottom, x minus 3 cancels with x minus 3, so 4 times x squared gives us a 4x squared. And then we have to be careful here. So we have minus, right? The x squareds will cancel, so we have minus 5 times x minus 3. So we'll have minus a 5x minus 15. And so when we distribute that negative, that's going to leave us with 6x squared on top still. And running out of room on the side here. But 4x squared minus 5x plus 15. So again, we have to be careful and make sure that we distribute that negative there. Okay?